Hello everyone. In this session, I am going to discuss most important question in the subject applied physics, that is for triple history. Moving on to the discussion. The first question. So I have seen this question in several question paper. Explain de-Broglie hypothesis. You need to derive an expression for de-Broglie wave equation. Okay. The second one is set up time independent Schrödinger wave equation. This is also very important. Schrödinger wave equation. So you need to study that particular derivation. Also, state and explain the Heisenberg uncertainty principle. Show that the electron does not exist inside the nucleus on the basis of Heisenberg uncertainty principle. That is also important. Next is actually you have to explain the Eigen value and Eigen function for a particular 3D box. Next is explain the different type of polarization mechanism with the suitable diagrams. So what is polarization? And along with that, you have to explain with the necessary diagram. That is also important. Another one is what is BCS theory? State and explain BCS theory. Then derive an expression for Classius-Mossotti equation for dielectrics. Okay. A few steps are available. Try to adopt those particular steps. And mention why you are explaining about Classius-Mossotti equation. Discuss different type of superconducting material. What do you mean by superconductivity? So what are the different examples of superconducting material? Those phenomena you have to explain. Okay. So you, if possible, draw the graph of superconductivity. Fine. So you can mention about the behavior of some material during certain temperature. Okay. So that is very important question. Question number 9. Mention any 3 assumptions of quantum theory of electron quantum theory. At least you have to mention any 3 assumptions. Discuss the dependency of Fermi factor on temperature and consequent effect on probability of occupation of energy level. Then explain the construction of maglev vehicle. Very, very important. Maglev vehicle. What is maglev vehicle? How does it work? Derive an expression for energy density of radiations of Einstein coefficient. There are certain mathematical equations that you need to incorporate. Describe the construction and working of carbon dioxide laser with a suitable diagram. So explain the applications of laser, light amplification by stimulated emission of radiation, that is called laser. At least you have to explain the applications. There is a separate portion for laser. What is numerical aperture? Mention the equation. Obtain the expression for numerical aperture in the optical fiber. Very, very important. Optical fiber works based on the total internal reflection. So you have to explain that particular terminology. While designing the OFC cable, we require this particular ratio. Discuss the different type of optical fiber. Classification of OFC. What do you mean by attenuation? Write down the formula. Different types of attenuation in optical fiber. That also you have to explain. Okay. Attenuation is one of the important parameter. Describe the point-to-point communication system with the help of a block diagram. Okay. I have seen these questions in some university question papers. So please pay the attention. Try to practice once again. This session will be helpful those who are doing the revision. Another one is actually describe the point-to-point communication system with the help of a block diagram. That is already covered. State and prove Gauss divergence theorem. In mathematics also we are learning Gauss divergence theorem. Then question number 20th. Derive wave equation in terms of electric field using Maxwell's equation. The same thing you will be learning in field theory if you are belong to EEE or EC background. Maxwell equation, wave equation is most important. What is displacement current? Derive an expression for displacement current. With the help of gradient of scalar, divergence, curl of a vector, derive a Gauss divergence theorem. Okay. So you might have heard about the del, one of the operator del. So you should have a brief explanation about what is partial derivatives. What do you mean by del? All those things. Then elucidate the transverse nature of EM wave of linear polarization. So you have to explain with the help of a waveforms. Derive an expression for electrical conductivity of intrinsic semiconductor. Write down the expression as well. What do you mean by Hall effect? Obtain the expression for Hall voltage in terms of Hall coefficient. So you might have heard about the Hall effect sensors. Okay, explain the phenomenon you have to explain. Derive the construction and working of semiconductor diode laser with the help of an energy level diagram. You have to mention about the valence band, conduction band, forbidden energy gap. So with the help of that particular diagram. Derive the relation between Fermi energy and energy gap in the intrinsic semiconductor. This is also related to band theory. You should have a thorough knowledge about the band theory. So what is valence band? What do you mean by conduction band? Okay, accordingly you can explain easily. So try to draw the diagram as much as possible. Evaluator will be mainly concentrating the diagrams, equation, etc. Explain how the resistivity of a semiconductor is determined using the for probe method. Mention any two applications of for probe method. Explain the construction and working of photodiode. How does it work? You have to mention the diagram. Okay. Then discuss the power responsivity in a photodiode. Draw with respect to the graph. So you have to explain the what is the how does photodiode operate. It's one kind of transducer. Then compute the de-Broglie wavelength of a neutron with the 1/10 part of the velocity of light, even mass of neutron, that is equal to already given. Even you can refer the data book also. Now university is providing the data handbook, that also you can refer. But you have to remember the de-Broglie equation. I hope that particular equation is also available in the data handbook. A particle of mass 0.5 milli electron volt per c square has a kinetic energy of 100 electron volt. Find the de-Broglie wavelength. So that de-Broglie equation is very important. I request you to go through that once. Also, you can check the data handbook. Mostly it's available. A spectral line of wavelength of 5461 Armstrong has the width of 10 raised to minus 4 Armstrong. Evaluate the minimum time spent of the electron in the upper energy state. That is also one of the numerical example. Similarly, another example is an electron is bound in a dimensional potential well of width 1 Armstrong, but of the infinite wall height. Find the energy values of the ground state and first two excited state. You can refer that particular data handbook. You will be getting some equations and some cases. So that based upon that, you can answer it properly. Question number 34, calculate the probability of an electron occupying in the energy level of 0.02 electron volt above the Fermi level at 200 K and 400 K material. You have to calculate it separately. Find the relaxation time of the conductor electron in the metal resistivity of 1.54 into 10 to the power minus 8 ohm meter if the metal has 5.8 into 10 to the power 28 conduction electron per meter cube. So another problem related to polarization, that also you can have a look on that. Similarly, there is another problem related to the lattice structure. Okay, the dielectric constant of a sulfur is given, assuming the cubic lattice structure, and calculate the electronic polarizability of a sulfur. So you need to understand what is a lattice structure of and cubic structure, all those things. Then another question is related to the transition temperature, calculation of the transition temperature. Okay, can go through once. Similarly, there is another problem related to laser. Okay, so kindly go through the particular question. Similarly, one more question, find out the number of photons emitted per seconds by the laser source. There are different data they have given. Wavelength is provided, power is given. So you need to calculate the how many number of photons that is emitted from the laser. So question number 41, the refractive index of the core and cladding is, it is related to OFC. Okay, optical fiber communication. N1 and N2 is provided. Okay, refractive index N1 and N2. Find the numerical aperture and angle of acceptance. One of the easy question. If you know the formula, directly you can apply. Then question number 42, the angle of acceptance of optical fiber is 30 degree when it kept in the air. Find the angle between acceptance and when the medium of refractive index is 1.33. So that also one of the important question. Let me cover remaining few questions. Kindly request you to go through these important questions because there are probability of asking this question many times. Question number 43, it is related to calculation of attenuation constant. Okay, there are formula related to attenuation constant. Make use of that data book also. Similarly, it is related to that vector calculation, divergence. You need to apply the Gauss divergence theorem. Determine the constancy such that the vector is provided. Okay, you have to calculate that particular formula. Then similarly, this equation is also related to calculation of curl F, del cross F. Del cross F. You might have heard about del cross F. You know how to calculate del cross F. Directly you can apply. So del is an operator. I into dou by dou x plus j into dou by dou y plus k into dou by dou z. F is already given. You can do that direct operation, curl operation, del operation, curl operation, scalar function, vector function, everything you might have familiar. So those who are doing the revision, kindly recall the formula, try to work out yourself. Similarly, what is the value of A and B sector if it is irrotational? Irrotational, there is a special condition. Apply the condition when it is irrotational. Okay, so there are there are standard thumb rule for computing that. Okay, special condition you have to remember. Del cross F is equal to 0. Del cross, you have to find out that. Calculate the number of donor atoms which must be added in an intrinsic semiconductor to obtain the resistivity of 10 to the power minus 6 ohm meter. Resistivity is given. Okay, so you have to calculate the number of donor atoms. Okay. Similarly, another question is also related to semiconductor physics. You have to calculate the Hall voltage. There is a formula. Whenever you are studying the Hall effect, there is a formula of magnetic field strength. That formula you have to recall. Then following data are provided related to intrinsic germanium at 300 Kelvin. So Ni is already provided. Similarly, calculate the resistivity of the sample. So here also you can use that particular equations. So these are the most important questions. At least if you cover, no, definitely you can anticipate a very good score in your applied physics subject. So I wish you all the very best for the examination. So this video you can watch once you completed the revising all the portions. Definitely it's a revision part. Thank you so much for watching this video. Happy learning. I wish you all the very best for your examination. Thank you.